Hi everyone! Before we start today's lesson, there are a couple of vocab words that I want us to understand before we try out some of these computations. The first word we're going to look at is reciprocal. So the official definition is the multiplicative inverse of a number x, also known as 1 divided by x. But when we think of a reciprocal, we're probably used to seeing that we just have to switch the numerator and denominator. So let's look at some examples. For instance, when we take the reciprocal of a number like 3 over 4, we flip or switch the numerator and denominator. So the reciprocal is 4 over 3. Okay, this can happen with any fraction, any rational number, even whole numbers. Think about the number 7. Okay, 7 is technically over 1, so its reciprocal is 1 over 7. All right, even with a negative number, if we do negative 5 over 9, the reciprocal is negative 9 over 5. All right. So again, reciprocals, you just switch the numerator and denominator, and that's the number we get. The next vocab word is rationalize. So when we rationalize, we eliminate a radical in a denominator. So what does this look like? Okay, so we're going to need a fraction. Let's say we have 7 over 2 times root 5. So what is wrong with this? We see that there's a radical or a square root in our denominator. So when we rationalize, we want to eliminate it. So how do we do that? We're going to take this square root, in this case square root of 5, and we multiply it to the numerator and the denominator. Next, we're just going to multiply across like we would any fraction. So 7 times 5 gives us 7 root 5. And now with the denominator, multiply whole numbers to whole numbers, radicals to radicals. So for 2 just gets multiplied to 1, right? There's an invisible 1 out here. So 2 times 1 gives us 2. And now root 5 times root 5, that gives us square root of 25, which just gives us 5. So in the denominator, we get 2 times 5. Okay, so what happened here? When we multiply root 5 times root 5, the square root essentially eliminated. The final step here, we get 7 root 5 in the numerator, and 2 times 5 is 10 in the denominator. Typically, we also want to check if these whole numbers in the numerator and denominator can simplify. All right, so here we have 7 over 10. So 7 over 10 cannot simplify. That tells us that this will be our final rationalized answer.